Hello guys, welcome back. This is Krishna again and welcome to AI Martian. This is all about deep learning series. So yesterday I talked about optimizers, right? In optimizers, I talked about a segment called derivatives. Now, I told you yesterday to get optimized value of loss or reduced loss, okay, which we calculate using MAE, MSC, categorical cross entropy, binary cross entropy, right? We have to reduce that loss, means whatever loss we will get in each epoch, we have to reduce that up to the global minima. Now I also told you like what is global minimum. All right, I draw a graph on xy axis and I show you like a kind of curve, u-shaped curve was there, and the bottom of the u-shaped curve was the global minima, right? So my model always try to calculate loss, and on the basis of W and B, means weight and bias. Two variables are there in the equation of y is equal to x plus c, or WB plus x, both are same. I told you that. So we simply try to reduce the loss and want to reach up to global minimum. If we will draw a graph of the loss function and weight bias, okay, on x, y, z axis. Then in that case, we will get such kind of graph. I will draw that again. But you know what? We required partial derivative of that because we have two different variable in that function. Y is equal to wx plus b. So we have to consider each variable separately. Okay, we have to calculate two derivatives, first with W and second with B, right? So I just want to give you one example, like what is partial derivative. I'm not taking you there in y is equal to W plus B, but I just want to show you in this video like what is partial derivative. So whenever I will tell you like we are calculating partial derivative or machine learning or deep learning model internally calculate partial derivative, you guys have to relate with this video, right? So let me show you that. Let's go to Google Colab Sheet because I have to draw something on the board. All right. So partial derivative is nothing but a simple concept. Let's say you have, one second. Let's say you have a graph, something like this. Okay. This is x-axis, this is y-axis, and this is z-axis. This is loss, this is weight, and this is, let's say, bias. Okay. So a kind of a U-shaped curve like this. Okay. Not like this, exactly like this. Okay. And this is the global minima, and it is on 3D, right? It is on 3D. Just try to understand. It is on 3D. Let me use another color for this. It is on 3D, let's say. Okay. And this is the global minimum. Okay. Is the lowest value of this graph. Okay. Where lows will go down, 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 and down. Right. And weight and bias both are playing role in this. So we have two parameters. So we have to calculate a partial derivative with respect to W and B. Okay, because we have two variables. Now I just want to show you one example. Let's say I have a formula or function f, okay, a function f where I want to calculate a derivative with respect to x and y, and the expression is something like x square plus y square. Okay. Now, if somebody will ask me, Krishna, calculate a derivative of this function. Okay. So I will say, okay, uh, d upon dx with respect to x, I'm calculating derivative. All right. So I will say, I will keep x square here. Okay. And when I will calculate derivative of this, all right, I will get this 2 in front and x. This is the derivative of x square in this expression. Whereas somebody will ask me, Krishna, calculate derivative of y. So I will say, okay, y square. And again, this 2 will come in front of it, and a y would be there. So if you will guys see, means in this expression, I did not consider this y square. I considered it as constant, okay? And constant value is 0, okay, when we calculate derivatives, okay? So similarly here we have, again, I take the same equation because I'm calculating a derivative with respect to y. So I consider this x square as constant, and that constant value is 0. Means that value are there, but that value are 0. And that's why we are not representing this value in our expression. And this is called partial derivative. All right. So similarly, we have two parameters. Okay. So we are simply we simply calculate derivative with respect to w and you can say b. In the expression y is equal to wx plus b. Okay. So this is all about partial derivative, and it's simple use to reduce loss. That's it. Reduce loss. And yesterday I made a graph, okay, on 2D axis. So this is the global minimum. So after each loss function in each epoch, okay, the optimizer work, and that optimizer calculate derivative, or you can say partial derivative, calculate partial derivative, and tell model to reduce loss by adjusting weight and bias. Okay, it simply change weight and bias. Okay, so again, my model get trained with a different weight and bias just to see whether the loss is going down or not. So after completion of first epoch, the second epoch start with this weight and bias. Okay, and that weight and bias simply help us to get a new loss. So here we get, let's say, loss 1. Here we will get loss 2. This loss may be lower than this one or may be high. It's totally on our training. Okay, so this is the all concept behind partial derivative, like how we use partial derivative. We have learned in school in 11, 12 classes. In ICSE board, there was like 8 or 9 classes. They already teach the partial derivative, I guess. So we always try to understand like where we will use such kind of stuff. So those stuff we use in deep learning, machine learning very effectively. All right. All right. So, guys, hope you understand this concept. Okay, if you really enjoyed, please like, share, subscribe, share with your friend, families, and let me know in the comment section if you are guys getting any kind of issue. You can connect with me on WhatsApp, Telegram. Right, I already mentioned the link in the description below. Right, just go through it, and thank you very much. Thank you for watching. Keep watching, keep learning.